You can try many other variations depending on where to put the rubber bands, and also using more paper clips. Let me show you 1 or 2 examples. We have tried the position number 1 or position number 2, but one position that we have never tried, this is quite interesting, rubber band in the middle. And it has to stay on the paper, and you can put the paper clips and see what happens. Rubber band now in the middle here, and paper clips at the top. So now what's going to happen? When I pull, this is what happens. So rubber band is hanging from the paper ribbon, that's okay. But those 2 paper clips got linked against each other, but each one of them is linked with the rubber band. So they are all 3, if you like, 3 circles are meeting in the middle, and any 2 of them being linked.
Not Borromean.
It's not Borromean because even if I make, for example, the rubber band disappear, the 2 paper clips are still linked, and so on. So you can probably guess at this stage what's going to happen if I put the rubber band in the same position, but one paper clip at the top, but the other paper clip at the bottom. So paper clips are on the wrong sides of each other. So now what's going to happen when I pull? Do you have a guess? Interesting. Let's try this. That's interesting. It looks like the previous one, but this time each paper clips is linked with the rubber band, but not between themselves. Let's finish with something that is work in progress. So far, we have been linking paper clips together, and sometimes we refer to this as addition. I mean, 2 paper clips coming together, so it's like adding. What about subtracting? By which I mean, can we start from 2 paper clips that are linked already and slotting them in some configuration on bent paper? Can you take them apart? Now, I tried many different possibilities, and it turns out that this time the orientation matters. You can link paper clips in many different ways. For example, you can link them here, or you can link them, for example, here, or you can link them here, and so on. So the position matters. And also, you can link them like this, or you can turn the paper clip around and you can link them right like this. It's very confusing. So let's try to link them here and see how we fare. It turns out that this kind of link will end up tearing the paper and just distorting the paper clips, and it ends up in a disaster. Also, I think, because you see I haven't done this many times, so I have to be very careful each time. But if I change the orientation of the paper clips and put them in this configuration, that's the right configuration. You may not see much of a difference, but the key is how those are linked at the top. Let's do it very carefully. Those 2 paper clips are already linked. I bend the paper in that standard position, but I slot the paper clip here and here by allowing this linked pair to straddle over the paper like so. Here and here, like this. Okay? And then I slot them very carefully. And here is the preparation. Paper clips were linked. Now I pull the ends, and hopefully this works. If it doesn't, we'll be very sad and some disaster happens. Okay, let's see. We'll be able to do it. They came apart. So we can now subtract.
You like that, don't you?
Yeah, no, that's very nice. They come up, you can make them come apart. Yeah. Computation or calculation in general, we always think naturally, because that's how we learn these things in school, about numbers, calculating with numbers, or perhaps at the more advanced level, calculating with formulas. And you do some algorithm, you do some recipe, and then the expected results come out. But here, your brain, although it hasn't formalized anything, it hasn't written any numbers or formulas, has effectively computed.